In inverses part 2, the next thing we need to do is try to find the equation of an inverse. And I'm going to start with something very simple. So I'm going to start with y equals 2x minus 3. This is sort of my default linear equation. And what we did in part 1 was we would start by making a table of values. So maybe I would do x is negative 3, so y is negative 9. X is negative 2, so y is negative 7. Negative 1, negative 5, 0, negative 3, 1, negative 1, 2, 1. That probably works. So there's negative 3, negative 9, negative 2, negative 7, negative 1, negative 5, 0, negative 3, 1, negative 1, 2, 1. That's good enough. All right, so there was my original function. And we said that the inverse is what you get when you switch the ordered pairs. So here's negative 9, negative 3, negative 7, negative 2, negative 5, negative 1, 0, negative 3, negative 1, 1, and 1, 2. Well, what's the equation of that purple line? So one of the ways that I can find the equation of the purple line is I can use 2 points on the graph, find the slope, and then I can find the y-intercept using something called point-slope form. So here's a review of something you might have learned in Algebra 1. The slope was y2 minus y1 over x2 minus x1. So if I use these two ordered pairs, y2 minus y1, watch for those double negatives, over x2 minus x1. Those two negatives make a positive, so negative 3 plus 2 is going to be negative 1, and negative 9 plus 7 is negative 2, and those two negatives go away, and I find out that the slope is 1/2. So in the equation y equals mx plus b, I know m is 1/2. What I don't know yet is what's the y-intercept b. To find the y-intercept, I'm going to use either one of the ordered pairs that I used in the slope. Why don't I use the first one? There's something called point-slope form, which is another form of a linear equation that you should have at least seen. Point-slope form is y minus y1 is equal to mx minus x1. So I'm going to plug in negative 9 for x1 and negative 3 for y1. Y minus negative 9 is equal to 1/2, because we already found the slope, x minus, I already forgot what I'm doing. Let's see, this should be negative 3, and this should be negative 9. So I get y plus 3 is equal to 1/2 x plus 9. Well, here's where it gets not so pretty. I'm going to distribute the 1/2. I'm going to get 1/2 x plus 9/2, or if you want to call it 4.5, you can. But I'm going to just use my calculator to get the exact fraction. And then I'm going to subtract 3. So if I do in my calculator 9 divided by 2 minus 3, math enter enter, I'm going to find out it's 3/2. Another way of writing this is x plus 3/2. Sometimes people forget that you can combine the two fractions into one if they have a common denominator. Now, that was a lot of work. Is there another way that I could have found out that the equation of the inverse was x plus 3/2? Yes, there is. So here's the algebraic way of doing it. You could have switched the input and output. Because remember, we said that an inverse occurs when you take the ordered pairs and you switch them. So x becomes y, y becomes x. So if I switch x and y, and then I solve this equation for y, because that's what we normally solve equations for, I would first add 3 to both sides, because in order to get rid of minus 3, you have to add 3. And then to get rid of the 2, you have to divide, because that says 2 times y. And hey, look, there's the equation that I just got doing all this work from Algebra 1 that you may not want to have to do. Let's try this again, because not all of our equations are this easy. This equation, y equals x minus 2 squared plus 4, is a quadratic equation. You know when you graph it, you're going to get a parabola or a U-shaped graph. So what is the inverse going to look like? To find the equation of the inverse, you switch the input and output. It's just that in this particular problem, after you switch it, you're going to solve for y. Here's where it gets tricky. You need to use inverse operations to do this, and sometimes students get confused. You first move anything that can be moved by adding or subtracting. Then I can't add that 2 that's inside the parentheses because there's a square on the outside of the parentheses. So I have to get rid of the square next. The inverse of squaring is square rooting. Then I can add the 2. But when I add the 2, I cannot put it underneath that square root sign. I need to make sure it's outside of it. And my other favorite part, you need to put a little plus or minus sign in front. And then I'm going to get plus or minus the square root of x minus 4 plus 2. And that is the equation of the inverse. Now you could have gotten the graph of the inverse, but how are you going to get the equation? Getting the equation from the graph is not easy. It's easier for linear equations than it is for any of the other functions. Some of our functions are not easy to work with at all, so I'm working with the easiest of our functions. Here's a square root. Y equals the square root of x plus 3 minus 1. How do I find the equation of the inverse? Well, we're going to switch the domain and range, and then we're going to solve for the range. You need to first move anything that can be moved by adding or subtracting. So I get x plus 1 is equal to the square root of y plus 3. You can't get rid of the the plus 3 that's under the square root because of the square root sign. So next, I have to get rid of the square root sign. The opposite of square rooting is squaring, but I want you to notice what I squared. I squared everything on the left-hand side. Then I can subtract the 3. And that is the equation of the inverse. Notice that the inverse of a square root function is a quadratic. On the previous page, the inverse of a quadratic was a square root function. The inverse of a linear function is another linear function. And that is an introduction into finding the equations of inverse functions.